continuous equations using reduction Echelon form, we first of all get out the coefficients of these values of x, y, and z. We have to take note that they are supposed to be in order x, y, and z. Then we get out the coefficients. When we get out the coefficients, the matrix, we put them in the matrix, which is a 2, 1, 4, -3, 2, -1, then we have -1. Then these ones, they are multiplied with the matrix x, y, z being equal to 2, 7, 5. Now when you reach here, what we are going to do is get these values that on the right hand side, leave them as they are, we join them to this matrix such that we have a matrix we can call to be N to be given by 2, -3. When you write it as this, 4, then I have -3, 2, -1, then I have -1, -3, 2, then this is a separating line, then I have a 2, I have a 7, then I have a 5. Now, what I'm interested in doing is making sure that this value is a 0, this value is a 0, this value is a 0. So what I have to know is I have to make all these values a 0. After making these values 0, then I can get the values of x, y, and z easily. So we know that this is the first row, this is our first row, row 1, then this is row 2, then this is finally row 3. So how do we make this first value to be a 0? The function is written here on that row. So for me to make this one a 0, it is simply going to be 2 of row 2. Then I subtract off what? Row 1. This implies that it is going to work on all those ones of row 2. So row 1 is unchanged. It's a 2, -3, -1 being separated. Then I have a 2. Then I have, we are saying that is becoming what? 0. Then 2 times r, so it is 2 times 2, it is 4. Then minus that becomes what? 7. So I have 2 times -3, then minus 1, we have -5. Then we have 2 times 7 minus that, what is 12? This is, because this one is going to be separated back, let me use another color. Then row 3 hasn't been dealt with, so we leave it as it is, as a 4, -1, 2, and finally what? Finally 5. Now we have successfully made this a 0. Our next goal is to make this a 0 also. How do we do that? Making this a 0, still we are going to deal with row 1 and row 3. Initially it was row 2 and row 1. So this time around it's going to be row 3 and row 1. Because we can't use row 2 here, because we already have a 0. There are so many, we are going to have a 0 throughout. For example, if you multiply. So this time around we shall have to say the function we use, we shall say twice of row 1, this gives it a 4. Then this one will simply be minus row 3. So we shall have this one remaining as it is, 2, -3, -1. Then we have a 2 there. Then we have, this is a 0 remaining the same. Why are these remaining the same? Because I'm on row 3 now. So this has to remain the same. This is -5, and this is a what? We got this as a 12. Now, when you get here, we are saying 2 times R1, which is a 4. Then this is a 0. Then we proceed 2 times R1, which is a -6. minus 1 gives us
negative 5.
-5. Then 2 times -1 will give us -2 minus 2, -4. Then we have 2 times 2, which is a 4. Then 4 minus 5, we have a -1, which we can represent with another color like that. So we have successfully made this a 0 and this a 0. The remaining battle is to make this a 0 also. This one here. How do we make it a 0? It is simply going to be, get this value 7, multiply it with this row 3 plus, then you get this value. Let me get it as a positive, because there's a negative, they will have to cancel like that. So you find that in the last one, I'm having root 1, root 3. This is when root 3 and root 1 together in the last one. So this remains the same, this remains the same, then this one is going to change a little bit. And what shall it be? It is going to be 2, -3, -1. Then we have this remaining the same, 7, -5. Then these are being separated from, this is a 2, this is 12, this is going to be a 0, this is going to automatically be a 0, because we are saying 7 times this gives us a -35, then plus 5 times 7, positive 35. So automatically that's a what? A 0. Then we come and say 7 times -4.
7 times
It's a -28. Then we are adding on plus 5 times -5. Negative. It's a negative. That's which will give us a -53. Then we look at this last one here. We are saying 7 times -1, -7, then plus, what is 5 times 16? It's a 60, so it will give us a 53, which is supposed to be in this color, like that. This is our n. Remember, it is our augmented matrix like that. Now, what we are going to do next is we are going to take back this one, the right hand side, then we bring back the x, y, z. Because we have successfully made this a 0, and a 0. That is just enough there. So you can even proceed from there, but that is just enough to solve these equations for you. So what we are going to do, I'm going to borrow some space here and write it back as 2, 0, 0, -3, 7, 0, then I have -1, -5, then -53. You bring back the x, y, z that we took away, the x, y, z. This one is equal to, these values have changed. They are the ones in red. And we shall have 2. We have a 2, we have a 12, and we have 53. That is what we have. Now, we are going to use multiplication. We are multiplying, this is a matrix, row by column. We start with the bottom. So it is a 0 times x, which is 0, plus 0 times y, which is 0, then plus -53z being equal to 53. So this one will equal to this. So what is the value of, I don't have space, so z becomes what? -1. Then now I come to this one here. I said you start from the bottom going upwards. So we start 0 times x, then 7 times y, then -5 times z. This is equal to 4. But we have the value of z as -1, so it is going to be 7y minus 5z So this is already a 5. When 5 crosses equal signs, it becomes a what? So y is equal to 1. Then we come back to this one here. From bottom to top. So now it is 2 times x, which is then minus 3y. Then this is equal to 2. You realize it is actually the same, but that one doesn't matter. We substitute in the values here. This is 2x minus 3. The value of y is 1. Then minus z, which is negative 1, so it becomes a plus, is equal to 2. So we have, this is going to be, when a 3 goes there, so it becomes a positive, so that becomes 5 minus 1, which is a 4 divided by 2. X is just a what? A 2. So we conclude and say, therefore, the values of x, y, and z are given by 2, 1, and negative 1.